Welcome to this lecture. Concurrency control is our next topic and it is very interesting. How to manage replicated data items. We know that in distributed databases, our fragments are at site 1, 2, 3 are divided at different sites. So some advantages and some disadvantages of replication and concurrency control. Although replication of data leads to memory losses and also hard to manage, but it has some benefits also. We already discussed about these benefits. But here is the question: how to manage replicated data items? Insert same data at all the sites where same data is replicated. Also same for modification and deletion operation. Concurrency controlling techniques ensure that multiple transactions are executed simultaneously while maintaining database. So what is meant by that? Because if our database or number of databases are logically connected and related to each other, so if you want to update an atom or a data atom, you should update at site 5, site 1, site 2, site 3, site 4. So by using this technique, concurrency control, you can manage. So locking based concurrency control is the first step. Locking based concurrency control protocols use the concept of locking data atoms. A lock is associated to the data atoms. So these are the two types: one phase locking protocol, two phase locking protocol. Before use of data, first lock the transaction. A lock indicates that this data atom will be going to operate by a transaction. A lock is a variable associated with a data atom that determines whether read or write operations can be performed on that data atom. Locking based concurrency control systems can use either one phase or two phase locking protocols. For example, suppose I want to update data at site 1 and I am here at site 4, and site 3 wants to update data at site 1. So first I will lock the site 1 atom, specific atom, then I will update the atoms which is here at site 1. So first lock the atom, then use it. So locking means no one can use during the locking, only you can use. So first of all, one phase locking protocol is here: lock an atom during its use. Each transaction logs an atom before use and releases the log as soon as it has finished using it. This logging method provides for maximum concurrency control. So for example, if I want to use or change an atom which is in S2, so first log an atom during its use. So first lock the atom, then use it. So if you want to perform any operation which is in your transaction, first lock the atom, then send your transaction, and what you want to perform you can. So first lock the data atom, one phase locking protocol. Two phase locking protocol, the transaction comprise or consists of two phases. growing phase, shrinking phase. So in this technique, first acquires all the logs that you want. After completing your work, release all the logs so your transaction will be completed successfully. All locking operations proceed. The first lock release. The transaction comprises of two phases. In the first phase, a transaction only acquires all the logs it needs and do not release any log. This is called expanding over the growing phase. In the second phase, the transaction releases the logs and cannot request any new log. This is called shrinking phase because our task is completed. So unlock the data items after that. So timestamp concurrency control algorithms. So timestamp based concurrency control algorithms use a transaction's timestamp to coordinate concurrent access to a data item to ensure serializability. So in this technique, we are going to manage our concurrency control by using timestamp algorithm. Which transaction is older over which transaction is younger, we can identify by using timestamp. A timestamp is a unique identifier given by DBMS over DBMS to a transaction that represents the transaction's start time. These algorithms ensure that transaction commit in the order dictated by their timestamps. An older transaction should commit before a younger transaction, since the older transaction enters the system before the younger transaction 1. Commit transaction according to their sequence. So rules for timestamp concurrency control algorithms: access rule, late transaction rule, younger transaction rule. So first of all, access rule. This is very simple rule. Respect your elders. So when two transactions try to access the same data item simultaneously for conflicting operations, priority is given to the older transaction. That's why I am telling you that this is very simple rule. Respect your elders. This causes the younger transaction to wait for the older transaction to commit first. Late transaction rule: if a younger transaction has written a data item, then an older transaction is not allowed to read or write data item. This rule prevents the older transaction from committing after the younger transaction has already committed. And the third one is younger transaction rule. A younger transaction can read or write a data item that has already been written by an older transaction. So these are the simple rules